Hello, everyone. My name is Hernando Munivar. I'm the president of Candent Technologies, and thank you very much for tuning in to this presentation. I'd like to talk to you about our 250 kilowatt high power density turbo generator, which is under contract to the Marine Corps Systems Command Joint Intermediate Force Capability Office, or JIFCO, for their directed energy weapon systems, in particular non lethal systems. Now, to put the program in context, let me tell you a little bit about Candent Technologies, about who we are and about the things that we're doing and how we're doing things. We started the company back in May 2001, so we just celebrated our 20th anniversary a couple of months ago. And we did this for the express purpose of developing advanced technology in propulsion and power systems, specifically in areas that the primes don't normally will address. And we have a team of highly experienced, and I'm talking about decades of experience, very broad expertise folks in the team who are able to do many things in many various technology areas. Personally, I am, and I'm going to date myself, I'm a Vietnam veteran, retired military officer, aerospace engineer, former academic, currently an entrepreneur. And I love what we're doing here with these various technologies. And what is it that we're doing? Where are we? We are developing advanced technology for microturbines to be used in turbo generators, to be used for propulsion systems. We are developing small heavy fuel reciprocating engines, again, for auxiliary power, all kinds of different power generation sources. We're developing propulsor units for outboard motors. We're developing waste heat recovery systems. We're developing concepts for hyperelectric drive systems. So there are a number of different technologies that we are engaged into. Currently, we have 4 SBIR STTR projects. There's only 2 listed on the slide, but please remember that we had this thing called the COVID-19 that hit. And so we had sort of a delay of 14, 16 months, whatever. So since then, we've had added a couple of more programs to these here. And the present topic that we're talking about is the N132086. This is a sequential phase 2, high efficiency, high density, 250 kilowatt turbine engine driven power system. We also have an STTR with ONR code 33. It's a reduced cavitation, high efficiency propulsor, which has been highly successful so far. We have a program where we're doing some torpedo propellers. And we got another program where we're doing a compressor, an air compressor, electric driven for boundary layer control systems. And there's a couple of other things that we're developing in concepts as well for future programs. So we have a great deal of expertise, a very broad expertise, and we do a lot of things in different areas. So please don't hesitate to ask questions about those once you get a chance to go through the rest of the slides and contact us. Coming back to the topic at hand, I'd like to highlight some of the program requirements. The SBR solicitation, just to paraphrase, describes the objective of the program as being the development of a high power density prime power system for directed energy weapons. That means compact, lightweight, producing lots of power. The initial target for this system is the Joint Intermediate Force Capabilities Office, JIFCO, Active Denial Technology Non-Lethal Weapon, which is a microwave type of non-lethal weapon. The Marine Corps is actually the lead service for these non-lethal weapons. And JIFCO is the office in particular that handles that. The chief scientist is Mr. David Law, who is the sponsor of this SBIR as well. There are some critical requirements in the solicitation specific to the size, weight, and power. That's the swap parameter for the system. And those describe the average power output that they would like to have between 150 kilowatt to 250 kilowatt. And then the critical parameters are the specific power and that volumetric specific power to be certain here. The threshold is 6,000 watts per cubic foot. Objective is 16,000 watts per cubic foot. And then the mass specific output. They want a threshold of 100 watts per pound and an objective of 500 watts per pound. Now, keep in mind that a diesel, lightest weight, most efficient diesel will put out somewhere between 30 and 34 watts per pound. There are also specifications for fuel efficiency, electrical efficiency, with about a 96% for the generator head. The fuel type is JP8. Of course, the gas turbine can run on JP8 and JP5, JP4, diesel, and other fuels. To understand what is driving the need for a compact, lightweight, high power density power source for these directed energy weapons, we have to see that the power sources that are being used today are driven by diesels. For instance, the active denial technology weapon system is using a stripped down MEP 809 diesel generator set. That particular unit weighs 9,300 pounds and puts out 200 kilowatt. A stripped down version that is being used is around 6,200 pounds. So if you were to deploy that weapon system, you would have to tow a 10,000 pound trailer behind the vehicle that is carrying the weapon itself. Therefore, we need to have a system that is smaller, that can be fitted to the vehicle, that will enhance the mobility and transportability of the weapon system without hurting any of the efficiency that's required, and also to maintain the logistics footprint, that is, that you minimize the fuel burn to minimize the number of tanker trucks that you have to utilize to supply the system, minimize maintenance, and so forth. So how is Candent meeting the requirements for the program? And the answer is that we are designing and building a high power density solution that consists of a recuperated thermodynamic cycle gas turbine driving a high-speed generator. And that is, given the system, the smallest volume and weight versus any equivalent diesel system, is extremely reliable, has very few moving parts, has low maintenance requirements, meets the fuel burn requirements for the system. It has a very flat fuel consumption curve, just like a diesel. And like the diesel, at very low conditions, the fuel burns a little bit worse. So it has equivalent fuel consumption to that of a diesel. The actual technology is using a recuperated thermodynamic cycle, meaning that we take some of the waste heat that would normally be dumped through the exhaust to the atmosphere and recover that to preheat the air before it is injected into the combustor to mix with fuel for burning. And so we recover waste heat, meaning that we don't have to burn as much fuel to do the work. It is a very high-speed generator directly driven from the turbine shaft, so it does not require a gearbox, number one, and number two, because it is going faster, it is going to be smaller and lighter. And the heat exchanger is a state of the art microtube design, which gives us very high effectiveness and very low pressure losses. That is the solution that gives us a 250 kilowatt system with a weight of around 500 pounds and a volume less than 30 cubic feet for the stripped down version. And the mock-up that you see in the picture here has dimensions about 28 by 28 by 54. So it is a very compact system indeed. And we expect that by the time we complete everything, the system is going to be producing over 500 watts per pound. Now let's talk about the program status and where we are today. Obviously, we've done the phase one. We did preliminary design there, phase two. And then the base program, we completed the final design and the generator and launched the hardware procurement. Phase two option is completed again now, and the gas turbine long lead hardware was ordered. Prototype high-speed generator construction and assembly. That's a critical component, and then we had to demonstrate that to complete the option for phase two. We are now on the sequential phase two, which we launched in the fall of 2019, and that was to complete the heat exchanger for the recuperator, the design and construction, the electronic control system software, gas turbine accessories, and then we're putting together the prototype for a test. Unfortunately, some of those things have been delayed due to the COVID-19 problems with suppliers. However, we have been progressing in the TRL world from phase three at phase one through five at the completion of the phase two option. And we hope to be at TRL 6 when we complete the sequential phase two that we're working on today. Now let's go over the features and advantages of our high power density solution. In terms of swap, size, weight, and power, we have an order of magnitude better power density than a diesel. And also, we are so compact that the size of our machine is about 1/5 of the size of a comparable diesel generator. The lightweight is also a very, very important attribute because the weight of our machine is about 1/10 that of the MEP 809. In terms of efficiency, we have an extremely efficient machine. We have a purpose-built machine as opposed to other gas turbines that are being used by primes and others that are aeroderivatives that have been modified to try and do the power generation job, but are not optimized for the job as ours is. We have very low maintenance. A TBO versus a diesel is 2x or 3x time, and is extremely versatile. Dual use technology. We can use this not just to power directed energy weapons, such as the non lethal weapons, high energy lasers, but also as mobile power, auxiliary power in ground vehicles and naval vehicles. And we can use it for microgrid power. We can use it for standby, emergency power units. We can also use it in hydroelectric drive systems for marine vessels and ground vehicles. Looking at the transition to fleet, we are looking now at the possibility of having a TRL 6 at the time of completion of our sequential phase two, and do intend to demonstrate the technology to various other program offices, various DoD components as well. And so we will continue to pursue that and get the extra funding on the phase three to complete the program through TRL 8, which would allow us a great deal of flexibility with some of the other agencies. As I alluded to in the previous slide, the technology has a great deal of versatility, and it is dual use. So we have a great potential for commercial applications as well as various other military applications. All of that will give us a much larger market than we were looking at for single military programs. And we intend to exploit that to the hilt. As part of our transition strategy, we intend to continue to follow our business model where we leverage the team's experience and we focus on performing certain highest added value tasks in house and outsourcing the manufacturing to qualified suppliers. So we will also focus on the functionality and engineering of the product, meaning that we will make the simple, robust, and easy to manufacture, easy to maintain products. And that means we adhere to the KISS principle, keep it simple principle. And then we also have in the past talked to and continue to talk to other major players, primes in the industry, which would be advantageous to us since they already have global networks for marketing and support and so forth. And so we, because of the versatility of and scalability of the technology, we intend to continue to pursue other opportunities within the DoD and other federal and non-federal governmental agencies. And finally, in conclusion, I would like to thank you once again for listening and watching our presentation here. And I'd like to urge you, if you like what you've seen here and you think might be of interest to others, please do spread the word. Come see us, talk to us. We'll be happy to talk to you about some of the other technologies that we have in house that we're developing. And we will be glad to sign NDAs with you to be able to have a more extensive, in depth dialogue. Please do so. Our information is right here. And thank you very much again.